everyone, welcome to Botany Insider. So in this lecture we'll be discussing about one of the most important topic from the CSIR point of view. It is from the Ecology unit and the topic is the Lotka Voltera model. I'll try to simplify this model as much as possible because many of us find this model very complicated. So I'll try my level best to simplify it for you. So now let's understand about the Lotka Voltera model. So the Lotka Voltera model is actually a competition model. It describes the outcomes of the competition between the two species over the ecological time. So in simple words we could say that it is a model which shows the competitive outcomes over the ecological time, that is over the period of time what would be the outcome of the competition that is occurring between two species. So consider we have two species, that is species A and species B. So now depending upon what is the actual state of these organisms or these group of organisms, that is whether species A is very strong, species B is weak, or the vice versa case, what would be the outcome if these two species come in competition for each other? What would be the outcome? It is what is actually measured, or it is what is actually predicted by the Lotka Voltera model, which is also given the name of the Lotka Voltera competition model. So now what is competition first? We have already discussed about the competition in complete detail in the previous lectures. I'll put the links of the same in the description box so that you understand about competition in a much better way. So we have considered that we have two species, that is species A and species B. So now there could be three types, or there could be three ways in which the two species could exist together, depending upon whether species 1 is weak or species 2 is weak. So now let's understand about the same. So there are three types of the outcomes possible. The first one is the stable coexistence. So as the word suggests, stable coexistence. Co means together and existence means surviving. So when species A and species B survive together, and when is the condition this is possible? So this is possible when both of the species A and species B are weak in nature. So when we have species A and the species B, both of them are very weak and they cannot compete with each other with maximum force possible. So in that case, what would be the result? That these two species would be having a compromise with each other, that okay, both of us will stay in this particular area itself, but we would not be harming each other, and as a result there occurs a stable coexistence. So you have to remember that in case when both of the species A and species B are weak, that is the case when we have a stable coexistence as the final outcome of the competition. So the second one is the unstable coexistence. So the case in which there occurs unstable coexistence is when both of the species are very strong in nature, that is species A and species B, both of them are very strong, they both have very much energies to compete with each other, or they have the tactics to compete with each other. So what happens is that when species A gets burdened over the species B, or species B get burdened over species A, what happens is that these two species have an unstable coexistence. Sometime as a result of the competition there occurs that species A wins, and in the other cases there occurs that species B wins. So this is the case in which we have unstable coexistence, that is when both the species A and species B are strong in nature and they both have the capacity to outcompete each other. Hence there occurs a unstable coexistence between the two. The third one is the elimination. So in this case what happens is So this occurs when the species A is very strong and the species B is weak. So in this case what happens is that the species B would get eliminated. Why? The species A would outcompete the species B, and as a result the species B would lose out and hence it would get eliminated. In the other case what happens is that we have species B being very strong and species A is weak in nature. So now as a result of this, the species A would get eliminated and the species B would win. So depending upon whether species A or species B, which is strong in nature, it would decide the elimination of that particular species itself. So this was about the 3 possible outcomes in the case of competition between the 2 species that we have considered. Make sure you remember about this. Simple points to remember are, in case of stable competition, both of them are weak in nature. In case of unstable, both of them are very strong, and in case of the elimination, either of them could be strong in nature. So this was about the types of outcomes possible. So now talking about that what is competition, I have just tried to summarize it in the simplest way so that we could use this in this particular video. So there are various types of competition. It could be intraspecific, interspecific, direct, interference, exploitation, apparent. There are various types of competitions and their models as well. I have made a detailed videos for the same in the previous lectures. I'll put the links of the same. Please do watch them and get your concepts cleared. So now we have to understand about few points before we get to the formula part of the Lotka Voltera. The first thing is about the K. What is K? That is the carrying capacity. We would be using these terms in the formula. So I wanted to make each and every term very clear. Hence I have tried to define each one of them. The first one is K, which represents the carrying capacity. So now what is carrying capacity? So the carrying capacity can be defined as the species average population size in a particular habitat. The species population size is very limited by the environmental conditions like the adequate food, shelter, water and meals. So carrying capacity is actually, so consider this is the area. So in this area, what are the maximum number of organisms that could survive with a condition that these all organisms must be provided with sufficient amount of food, shelter, water and the meals. So that is what is actually known as carrying capacity. For example, consider we have this area and the carrying capacity, that is the K of this area, is 50. What does this mean? That is, this area could provide 50 individuals with adequate food, shelter, water and all the other resources that it requires for its survival. But if there occurs increase in this number, that is there occurs 55 individuals in the area where the carrying capacity is more. So now what would happen? Beyond the carrying capacity there starts to occur competition. Why? Because of less amount of food present. We have already discussed about the various conditions for competition or the factors responsible for competition, and one of the factor was resources. That is, when there are less amount of resources present in particular area, at that place there are high chances of competition. So this is about the carrying capacity. The next thing is about the isocline. So now what is isocline? In the complete topic of Lotka Voltera you would come across this term many times, isocline. So what is isocline as such? So it refers to the set of population sizes at which the rate of change for the one population in a pair of interacting populations is 0. This is very difficult to understand. So just understand this, that isocline is the area where there occurs activity of either the first species or the second species. It is represented by a line. So if there occurs this line and in the question or wherever it is mentioned that it is the isocline for species A, That means it is the area where there occurs the activity of only the first species or the species which is present. Or for example, and the second example is that consider we are given this diagram. Consider we are given this representation and it says that this is the isocline for the second species. So that means this is the area which is, so in this area there occurs the activity of the second species. Depending upon the question which is given, so we have to remember the same, that isocline refers to the set of population size at which the rate of the change for one population in a pair of interacting populations is 0. So you can see in this area the rate of change, the rate by which the population of this species, that is species 1, would change is actually 0, and in this case the rate of change for the second species is 0. So you have to remember about this thing itself. So now let's understand about the various symbols. So the first thing is that there is alpha represented. So what is alpha? So alpha represents the competition coefficient, that is when the two species that we are taking into consideration are actually competing with each other, what would be the level or what would be the unit by which they would be competing is represented by the competition coefficient. So we have two symbolic representations for the same, that is if it is written alpha 1 2 and if it is written alpha 2 1. So there is difference in the meaning of both. So in the first case, the way we have to read them is that if it is written alpha 1 2, so in this the effect of the second species over the first species, and alpha 2 1 represents the effect of the first species over the second species. You have to remember about this, that if it is written 1 2, so the effect of the second species, it could either be A, B, or depending upon the what is written in the question or what is used in the question. So we have to apply it in the same way. So if it is written 1 2, so it is the effect of the second species over the first species, and if it is written 2 1, that is the effect of the first species over the second species. So this is the first symbol that you have to remember. The second thing that you have to understand is that sometimes in the question nowadays alpha 1 2 is actually represented only by alpha and alpha 2 1 is represented by beta. So this is the new representations that are sometimes used in the examination. So you have to understand about, or you have to remember this, that if it is written alpha 2 1 or beta, it means the same, and if they are using this instead of this or the other way round, it means the same way, that they are actually talking about the effect of the second species over the first by using alpha, and if they are using 2 1 or beta, it is means that they are actually representing the effect of the first species over the second species. So this was about the competition coefficient. The next thing we have to remember is about the two conditions. That is, the first condition is when alpha 1 2 is greater than 1, and second is when alpha 1 2 is less than 1. So what we have to understand is that if there is more effect of second species over the first species, or the competition coefficient of the second species affecting the first species is greater than 1, so in this case there occurs interspecific competition. What is interspecific? So we mainly have two types of competition, that is interspecific and intraspecific. For example, we have species A and species B. So when there occurs the competition between the two species, it is inter. Inter means between and intra means within. That is when there occurs competition within the species A or within the species B. So this is about the intra and the inter. The second condition was that when the competition coefficient of the second species affecting the first species is less than 1. 1 is taken as the unitary value in the Lotka Voltera. So do not worry about that why I have taken 1. So it is the norm to understand the same. So if the competition coefficient of the second species affecting the first species is less than 1, so in this case this means that there is less of, or the second species is weak in nature, and if the second species is weak, that means the species 1 is strong in nature, and as a result there is more of intra-specific competition. Why? Because species 2 cannot take the risk of competing with species 1, which is strong in nature. Hence there is more of intra-specific, or there occurs more competition within the second species itself. So these are the 2 points that you have to remember, that if in case we have alpha 1 2 greater than 1, in that case there is interspecific competition, that is species 2 is strong, and in the second case if we have alpha 1 2 being less than 1, in that case there is more of intraspecific competition. So this was about the symbols. So now we have to understand about the various formulas that are used in the Lotka Voltera. So the first thing we have to understand is that when we look at the population growth, and in this the population is growing with the logistic growth, that is there occurs the S-shaped curve for the population growth. So in that case the formula that is used is dn upon dt is equal to Rn k minus n divided by k, in which R represents the intrinsic rate of increase, n represents the population size, k represents the carrying capacity. We have discussed about this. So now we have to understand about the first case in which the species A, so or the species 1 is in the initial case is growing alone. So we have the species 1 growing alone in nature, there is no competition for the same. So now what would be the case? So in this case we would be using only the n for, or the number of population for the first species that is growing. So in this case the formula would be dn1 upon dt is equal to Rn1 multiplied by K1, which is the carrying capacity for the first organism, minus N1 divided by K1. So this is the formula for the species 1 growing alone. So now let's consider that there comes the entry of the species 2. So we have now the species 1 growing with the species 2. So in that case what happens is that there occurs competition between the two species. So now because the second species is coming and affecting the first species, the competition coefficient that would be used would be alpha 1 2, that is the second species which has come at a later stage would be affecting the first species. So now what happens is that there occurs some modification in the formula. Initially we have the same dn1 divided by dt is equal to Rn1 multiplied by K1 minus N1. Till here the formula would remain the same, but now there occurs a change, and that is we would be subtracting the competition coefficient for the species 2 affecting the species 1, and it would be multiplied, or the competition impact would be of all the organisms, or of all the number of organisms that have come from the species 2. So we would be multiplying this competition coefficient with N2, and it would be divided by the same K1. There is no difference in the formula as such. The only change that have come is we would be subtracting the number of the species that have come, that is the number of organisms of the second species multiplied by the competition effect they are showing over the first species. So this is the formula that would be used if we are asked, or if we are given some of the values depending upon whatever the question is asked. This was about the species 1 initially. So now in the second case what happens is that there occurs species 2 growing alone, that is there is no competition for the species 2 as such. So what would be the formula? It would be dN2 divided by dt. It would be equal to R N2, why? Because we are taking the second species, multiplied by K2 minus N2 divided by the K2. This is when the species 2 is growing alone. But now what happens is that there occurs the entry of species 1. That is, initially the species 2 was growing alone, but now there occurs the entry of the species 1 in the area of the species 2. So now there must occur the competition between the two species, as initially it was growing alone, but now there occurs the entry of the members of the species 1 also. So there would occur competition between the two. So the change in the formula would be dN2 divided by dt, same. Then we have R N2 multiplied by K2 minus N2 minus, in the first case we have subtracted the competition coefficient of the second species affecting the first species. So in the same way, in this case we would be subtracting the competition coefficient of the first species over the second species, because initially the second species was living in peace, but now the species 1 have arrived and it has started the competition. So now we would be subtracting the competition coefficient of the first species over the second species multiplied by the number of the organisms of the first species, as in the case we did here, and it would be divided by the K2. And why K2? Because initially we have taken the K2, that is the second species was growing alone, hence here after the change also we would be taking the K2 itself. So these are the two formulas. All you have to understand is that initially the formula that is being taken into consideration is for the logistics curve. What do we mean by the logistic growth? So logistic growth is the growth in which there is limited resources present and there is reality, that is at a particular time there would occur the stoppage of the growth of the individuals. So in that case there occurs the formula being used as dN by dt is equal to Rn multiplied by Kn divided by K. There are two cases for the same. In the case 1 we have the species 1 initially growing alone, so we have the formula for the species 1 modified. So now there occurs the entry of the species 2 into the area of species 1. There occurs competition, so we would be subtracting the competition coefficient for the effect of the second species over the first. We did the same and we multiplied it by the number of the organisms that have arrived. And in the same way, in the case 2 also, initially the species 2 was growing alone, so this was the formula, but when there occurred the entry of the species 1 into the area of species 2, so we have the competition coefficient of the effect of the first species over the second species being subtracted from the same. So this is about the formula. I hope till here the formulas are clear to you. So now let's just quickly summarize it. So there occurs interspecific competition in case of the Lotka Voltera, that is these are the two cases when initially the organisms were growing alone and then there occurs the competition between the second species. So this is what we have just discussed. You can see that there occurs the usage of alpha and beta. We have discussed what is alpha and beta. Alpha is the effect of the individual of the species 2 that has an effect on the population of species 1, that is it is actually representing 1, 2, and beta is actually representing the effect of the individuals of species 1 that has a population growth for the species 2. So it is actually representing 2, 1. So this was about the formula. We have just discussed about the same. Till now we have completed all the formulas related to the same. We have one more topic left for the same, and that is about the rules of the isocline, that is in which we would be plotting the various graphs for the same. I would be covering up that topic in the next video along with the previous year question, because this video is getting quite long and I do not want to upload a very long video. Hence, we'll be solving the question and the rules in the next video. So till now, I hope the topic is clear to you. If you have any doubt till now, I would love to hear about the same in the comment sections and try to solve them as much as I can. So we'll be continuing the topic in the next lecture, and with this we're done with this particular video. And if you like this video, please do like, share it with your friends, and please subscribe to my channel. There is no subscription fees. You can get it for free and you can get all the notifications as and when I upload a new video. So thank you so much for watching and I'll see you soon. Bye.